Hey everyone, it's me, Miss B, and in today's video we are looking at the Unit 6 Lesson 9 practice problems from Illustrative Math Algebra 1. So let's dive right in. So it does say complete the following while showing all your work, so I'm going to do my best to show my work here, as you should always as well. So our first question is to write each quadratic expression in standard form. Draw a diagram if needed. So let's just write for ourselves what standard form is. This is ax squared plus bx plus c. So what that means is that all of our like terms are combined. So I don't have like multiple terms with just an x. I don't have multiple terms with an x squared. All of them are combined, and we're writing them with x squared first, then x, and then our constant number. So we want to make sure that our answer looks like that when we're done with it. So let's do this first one. Now we can, it says draw a diagram if needed. I think what they might be talking about is maybe our box diagram. So I'll do the first one using a box diagram. And just cut this in half, both directions. Okay, so then I'll do x plus 4 at the top. And when I use a box diagram and I have a minus, like x minus 1, we're going to keep that minus or that negative with the number. So then now I can multiply it like normal. X times x will give me x squared. The top right box will be x times 4, so that's going to be 4x. My bottom left box is going to be negative 1 times x, so negative 1x. And then the bottom right box will be minus 4 or negative 4 because negative 1 times 4. So now I do need to add all of these up, but the only like terms are these ones right here. So we're going to combine them. We'll get 4 minus 1 is 3. So this will end up being 3x. So x squared plus 3x minus 4 is going to be our answer. And that is in standard form. Now, if we didn't do a diagram, we could use the double distribute method. So that's what I'll show on this one over here. I'm going to take 2x, and the first thing I'm going to do is distribute 2x through this entire thing. I'm going to leave myself a little space underneath just to write because I'm going to do some more distributing. I did say it was double distribute. So 2 times 3 is 6, and x times x is x squared. Then I have 2x times a negative 1, so a minus 2x or a negative 2x. I'm going to use a different color here. I'll use blue because now I need to take this negative 1 and distribute it through over here to the right as well. So I'm going to write these ones here in blue. Negative 1 times 3x will give us negative 3x or minus 3x. And then negative 1 times negative 1 will actually give us positive 1 or plus 1 here. Now the same thing still applies. We are still going to combine these two terms right here. And that will give us negative 2 and negative 3. We're combining them. So it's like adding them together. So this becomes negative 5x. So we'll have 6x squared minus 5x plus 1. And this is the standard form answer for part B. Now you can do either of these questions in either method, just showing you the two options that you have, but you do have those two answers that you'll get no matter what. Okay, that brings us to question 2. Consider the expression 8 minus 6x plus x squared. Okay, so we're looking at this expression. I'm going to highlight it just so that I am keeping it fresh in my mind. Okay, is the expression in standard form? So is this in standard form? And then how do I know? I'm going to say for this one, no. because I'm going to say the quadratic term, to use the formal name, but quadratic just means the x squared term. Term should be first, and the constant term should be last. So we really do need to just switch their places. Last. All right, there we go. Now we have another question relating to it. Is the expression equivalent to x minus 4 times x minus 2? So we want to know, is it the same as this? And then explain or show how we know. Well, I'm not entirely sure, so let's multiply this out and see if that works for us. And I'm going to use kind of just the double distribute method. I'll do that in 2 colors still for the time being. So we'll do these first, x times x, and then x times -2. So we'll have x squared minus 2x, and we'll have minus 4x and plus 8. This will give us x squared minus 6x plus 8. Now, we said the other one was not in standard form. This one is in standard form, and it is the correct version. So we have, the only thing that might trip you up here is that it has like the -6 here in the middle. And we're like, okay, but I don't know what sign goes with 8. When you switch their places, 8 keeps the sign that's in front of it, which is an invisible little plus sign there. So we're going to say, yes, this is the proper standard form. And yeah, that's really, when we multiply it out, we get our standard form of that expression. All right. So that brings us to question 3, which is, which expression is written in standard form? So all of these are quadratics, but we want to know which ones are actually written in standard form. And one of the things you'll notice about standard form that I wrote at the top is I don't have parentheses here anywhere. So there's no implied multiplication that's left to be done. And in our first question, we multiplied everything out first. So pretty much if there shows that there's still some work to be done, then that's not going to be our answer. So for A, that's not our answer because that means we still have to multiply x and x plus 3. B is also not in standard form because that means x plus 4 times x plus 4. So then it's down to C and D. D, while the numbers are in the right order, right, x squared plus 2x plus 3, the fact that it has some multiplication we need to do here means it's not done, and it's not correct. So our answer here is C. All right, so now question 4 is a little more complicated. This one says, explain why 3x squared can be said to be both in standard form and factored form. So standard form has no multiplication left to do in it. It's written from left to right with our highest exponents first and then decreases to our constant at the end. But factored form is where it's written out as just single factors that could be multiplied. Now, I can't really pull anything out of this other than a coefficient. So this is just the single factor. So it is standard because it is in the correct, we'll call it correct order. Even though there's only one, you can't really put that in the wrong order. So it's standard because it's in the correct order and fully simplified. We'll say it is factored because now factored form is where we can no longer pull out a number to like divide by or that can be multiplied through all of the terms. So it is factored because we cannot factor out any other numbers or terms. Basically, it's really hard to factor a single term because generally when we factor something, that's something that we do to more than one term. And we find what they have in common. So technically, this is 3x squared is both. That then brings us to question 5. Jada dropped her sunglasses from a bridge over a river. Oh no. So we're dropping something. It's unfortunate that she's losing her sunglasses. But let's look at what's maybe important here in this question. So she dropped her sunglasses from a bridge over a river. Which equation could represent the distance fallen in feet as a function of time in t seconds? And then explain why. So when we fall a distance, we are not looking at height. So not height, which means this is going to start basically at 0 and then increase. When we have a constant term here, that is like in C and in D, where we're starting with the 180. That means we are measuring how far off the ground it is, or we're measuring the height. That's why we're not using that. And then it's falling, that height is decreasing, which is why we have the minus. Now, it is going to be A, and that is because of the t squared part here. Gravity is an acceleration, and accelerations are always squared. And if I go more into that, then this becomes a physics lesson. So it should start at 0 and get larger, but also be quadratic. So the reason why it's not B is because of this part here needs to be quadratic. So that's why we're not using B. Question 6 is our last question from this page. So, and then we'll flip over to the back. So a football player throws a football. The function h given by, now I'm going to highlight this because I always like to keep a good eye on my functions. H of t is equal to 6 plus 75t minus 16t squared describes the football's height in feet t seconds after it is thrown. So I feel like they should have a comment in here, height in feet t seconds after it is thrown, because it's not height in feet t seconds. So there we go. We want to select all statements that are true about this situation. So we want to figure out what is going on here. So let's look at our expression first and kind of narrow down what is happening. So we know our constant term, this one here, is starting height. We know that our linear term is the original vertical speed, so vertical speed. And then this minus 16t squared describes gravity, or it falling. Okay, so when we start out and we say the football is thrown from ground level, nope, because it is thrown from 6 feet. Now I don't have to write that in here because it's not asking me to explain, but I'm just going to. B is correct. The football is thrown from 6 feet off the ground. That is what makes A incorrect. Part C here says, in the function, negative 16t squared represents the effect of gravity. Yes, it absolutely does. That's what I literally just wrote an arrow to up above. So we know that that one is true. Let's read option D. The outputs of H decrease and then increase in value. So the outputs of H, this means the outputs of H is the height, not the distance fallen. So the height of this football is not going to decrease and then increase. It's going to increase and then decrease. So this is not true because it will increase, then decrease. And then that leaves us with two options left. We have the function h has 2 zeros that make sense. So let's highlight this and we'll talk about has 2 zeros that make sense in this situation. Okay, so a 0, this word 0, is what we can call an x-intercept. And what that means that the height is equal to 0 at 2 points for us that make sense. And I would argue that that's not the case. This football is actually starting 6 feet off the ground, like we saw in literally the part right above us. So if I drew a little graph of this, my football is going to start maybe like here. And then this is going to go up, and then it's going to hit the ground at some point. And this one right here is a 0. So I'm going to highlight in small this little part right here. That is a 0. That makes sense for us because we're measuring time. Now it does not make sense for us to go backwards and have a, oops, not an erase. I'm trying to show this here. And we're going to say, nope. That one does not make sense right there. The only one that does is the one to the right. So the entire thing here is not correct because there's only 1 0 that makes sense. And for the last part, this one says the vertex of the graph of h gives the maximum height of the football. So yes, because in this case we have a vertex will always be a maximum or a minimum. And then since this is the height of the football, it is going to be going up and then back down. And it is the height. So yes, F is true. The vertex will be our maximum height. Kind of like you can see in my little graph over here, the vertex is this point here. So that one right there, that's my vertex. And that is it for question 6. So that'll bring us to the back of this page, and we'll keep going. All right, so on the back here, question 7 is going to ask us technology required. That means we're going to use a calculator. So I'm going to use a graphing calculator. We're going to look at Desmos for this one. But let's read through our question first. 2 rocks are launched straight up in the air. The height of rock A is given by the function f, where f of t is equal to 4 plus 30t minus 16t squared. And then we have the height of rock B, which is given by function g, where g of t is 5 plus 20t minus 16t squared. So in both functions, t is time measured in seconds and the height is measured in feet. We want to use graphing technology to graph both equations. So I am going to pull up here our Desmos graphing calculator. So you can either plug these in using X, or if you actually say that you have H of T, then Desmos will behave a little bit better when we set things equal here. It'll treat it the same way. So let me go back and grab these numbers. We have 4 plus 30, and then we have 5 plus 20. And actually I was using H when this should be F. 4 plus 30 and 5 plus 20. All right, so this should be F of T, and then we're going to have G of T. So I believe this one was 4 plus 20t minus 16t squared. And if you're using your Chromebook, you can always type using your keyboard. But since I'm recording this on an iPad, that's why I have to pull up the other actual keyboard, which I'm using the ABC button there in the bottom left. So 4 plus 20, and then I think it was, what did I say, 5 plus 30? Oh no, 4 plus 30 and 5 plus 20. I'm already mixing it up. So 4 plus 30, and then this should be 5 plus 20t minus 16t squared. Okay, so I have red as rock A and blue as rock B. I'm going to squish this down and then zoom it in a little bit so we can actually see a little better what we have. So one of the first things it asked us about this, I believe, was what was the maximum height of the rock? So let's go back. Yes, what is the maximum height of each rock? And then which reaches its maximum height first? So we want to know not which one goes higher, but which one reaches that height first. So first of all, let's go and look at rock A and see what that maximum is. So that is going to be function f. That's our red one here. And you can see once we click on it, there is actually a gray dot at the top. That is the maximum. And so if you click on the little gray dot, it actually shows you all the values. So this one, the output value is 18.063. So that is going to be our maximum height. Oops, wrong one. I want this one. So 18, oops, I'm using my thick marker here. Have my thinner handwriting. 18.063, I think, was the first one for rock A's feet in the air. And then let's go look at rock B. This is gonna, whoops, this one is gonna give us 11.25. Okay, 11.25, we can do that. 11.25. So rock B definitely does not reach as tall, and we can see that from a graph. But we want to know which one reaches its maximum height first. And so that is dealing with time. So let's go back and look at our graph. It doesn't matter which one of these has the higher value. We're looking at t, and I wonder if I can make this into a slider. We're really looking at the time. So we're looking at the x value. We want to know, when is this one reaching its maximum height? And that's at 0.625 seconds. And if we look at our red one, this is at 0.9375. So 0.6 seconds or 0.9 seconds. The blue one is definitely going to hit its maximum first. So 0.625, that's function G, which is rock B. So let's go back and say it is rock B because T equals 0. What we said was 675. I'll go double check that number. At the maximum instead of t equals 0.9 something for rock A. So I'm going to go back and look and just copy my numbers over. So we had 625, I said 75, so I'll fix that. 625 and 9375, that's where I was getting that from. So 625. My bad. 625 and 9375. So it is rock B because it is sooner. 0.6 comes before 0.9. That's it for question 7. So that brings us on to question 8. Each day after an outbreak of a new strain of the flu virus, a public health scientist receives a report of the number of new cases reported by area hospitals. Now, this is asking, would a linear or exponential model be more appropriate for this data, and to explain. So let's look at what we have, and we'll just kind of see what our difference is, which is how we would look for how we would look for if it's linear. So what I see here is that this is going up by 8, but then looks like I'm going up by 10, and then by a lot more than that. So I would say, and also this one here jumps by 25, right? So we got a lot of different things going on here. 15, 60, 70, this is going up by 21. And 38 to 54 is 14. This is 16. I would say exponential because it is increasing by different numbers each time. linear would mean it should be increasing by the same number each time. And then the last question we have here is question 9. So this says A of t is the average high temperature in Aspen, Colorado, and t is months after the start of the year. M of t is the temperature in Minneapolis, t months after the start of the year. And temperature is measured in degrees. So looking at our graph, we're going to answer questions A, B, and C down here. What does A of 8 mean? So if we go back up, we remember A of t is the high temperature in Aspen, and t is months after the start of the year. So that is the average high temperature of Aspen in August. It was the 8th month after the start of the year, and A8 would be this blue one right here, so we can estimate that to be approximately, it looks like 75. Okay, which city had a higher average temperature in February? So we're going to look at 2 months after the start of the year, and that is going to be here. So this is Minneapolis, and this is Aspen. So we would say Aspen. And then were the two cities' average high temperatures ever the same? If so, when? So we can say yes. And then I'll just give t values for each of them. So at what time? Because I see them cross. So this looks a little bit in between. I'm going to highlight these actually because I'm going to have 2 of them. So right here, and it looks like they're the same right here. So this looks like it's a little bit past 3.25. And for our last one, I would estimate this one as a little bit past 9. So maybe we could say 9.5. And I'll say approximately for both because we're estimating. But yeah, showing those 2 highlighted places. And that is it for this assignment. It was 1 page front and back. So I appreciate you for sticking with me on this one. I'm sorry if it's a little noisy since I'm in a room with other people right now. But yeah, thank you for joining me. And then this was the Unit 6 Lesson 9 practice problems from Illustrative Math Algebra 1.